Hey guys, so here I am in my home studio, also known as my kitchen table, and we're going to do our first section of notes today. It's on section 2.1, linear equations and problem solving, and the first thing I want you to do, if you haven't done it yet, I want you to pause this recording and I want you to print out the notes. They're available to you on Schoology. It's very straightforward what it says, so go ahead and pause the video now. Okay. So, welcome back. As you can see, we have linear equations and problem solving notes today. I'm not going to go through every single problem because that's part of what I want you to do for practice for yourselves tonight, but I am going to go through some of them. Our steps for solving equations. First step is list any restrictions on the variable. Okay, just a reminder guys, this is a domain type question. Okay, so what do we have to do? We have to say, am I dividing by 0? I have to avoid that. So if x is in the denominator, I have to say that x can't equal 0. Or I can't make the denominator equal to 0. Our second step, if necessary, multiply by the common denominator to eliminate the fractions. First couple problems that we have don't have that problem. Step number 3, remove all parentheses and simplify. Step number 4, collect all variables on one side of the equation and the numbers on the other. And step number 5, simplify and solve. Check for extraneous answers, which are problems that had fractions with variables in the denominator at the beginning. So if it doesn't have a fraction, guess what? There's no extraneous answer. Okay, so let's take a look at number 1, solve a linear equation. What we have here, we don't have any fractions, so there's no restrictions. There is no common denominator because there's no fractions, so we have to remove all parentheses and simplify. Guys, you've done this before. This is very straightforward. This negative sign gets distributed through the parentheses, so this becomes 4x minus 2x plus 12 equals 6x plus 13. Okay. Now, the next thing, collect all variables on one side of the equal sign and the numbers on the other. Well, first, before I even do that, I'm going to go ahead and combine my like terms on the left-hand side because I have 4x minus 2x, and that's just simply 2x. I have 2x plus 12 equals 6x plus 13. Okay. Now, I'm going to put this, in this case, I'm going to put the variables on the right-hand side because I have a positive 6 over here and a positive 2 over here. If I move the 2, I can stay positive because, you know, I'm such a positive person, as you all know. So we have 12 equals 4x plus 13. I'll subtract that 13 from both sides. And I get negative 1 equals 4x. And then what do? Well, that's pretty straightforward. I divide by 4. And I get x equals negative 1/4. Now, I'm not going to say that you have to go back and put your answer back into the equation. That's a little bit ridiculous. But if you want to make sure that you're right, you can do that. There's nothing wrong with doing that, but I'm not going to take the time to do that today. Okay. So now let's take a look at number 2. Number 2 is very similar to number 1. The big difference is that we have what? We have negative 6 times 2x. So we're going to distribute this negative 6 across. We have 4x minus 12x plus 72, because a negative times a negative is a positive, equals 2x plus 13. Once again, I'm going to combine my like terms on the left-hand side because I've got some. So I got negative 8x plus 72 equals 2x plus 13. And once again, it doesn't matter which side I move to, which side I put the x's on, which side I put the numbers on. I'm going to say, oh, I'm going to get rid of this negative 8x by adding 8x to both sides. So I end up with 72 equals 10x plus 13. And when I subtract 13 from that, I end up with 59 equals 10x. And then, of course, I divide by 10, and I get 5.9 equals x. Okay. You guys have done this before. Okay, this is straightforward, easy stuff, right? But now we get to a problem like number 3. Now we actually have some fractions here, but the good thing is that x is not in the denominator, so we still don't have to worry yet about any restrictions. But we want to multiply by the common denominator to eliminate the fractions. Well, I've got 2/3, I've got a 1, I've got a 5/3, and I've got a 12. Well, a 1 on the denominator. So the common denominator there, hopefully you all see, is going to be 3. So I'm going to multiply everything by 3. Okay. So when I multiply by 3, 3 times 2 is 6 divided by 3. Well, that's the 2. We cancel out that denominator, so we ended up with 2x. Now remember, everything gets multiplied, so we do have to distribute. So we have 3 times -6, which is -18. Now, 3 times 5/3, that's going to be 5x. And 3 times -12 is -36. Please, 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 please make sure everything gets multiplied by that common denominator. If it doesn't, then we have a problem. All right, so now we just solve it the same way we always have. I'm just going to go ahead and do the next step. I'm going to subtract my 2x, subtract 2x. So I have -18 equals 3x minus 36. I'm going to add 36 to both sides. And I have 18 equals 3x, divide by 3, and I get 6 equals x. Okay? Make sure that all terms get multiplied by at least common denominator. I'm going to actually write that. All terms get multiplied by LCD, least common denominator. Okay, and now we're going to do number 4. Let's take a good look at this one. Number 4, we have an x in the denominator, and we have a 5 and a 4. So there's a lot of things that we have to think about here. First off, the x in the denominator. What does that mean to you guys? Well, that means that we have to restrict our domain, or we have a restriction on the variable. Obviously, we don't want x to be 0, because we'll throw you in math jail for that, because that's dividing by 0, and you all have heard that before. So we're going to we're just going to say x cannot equal 0. So when we get to our answers, if we have x equals 0, that would be extraneous, but we'll show you a problem that has an extraneous solution. Now, what is the common denominator between x, 5, and 4? Well, I've got an x, so I've got to include that, and the least common denominator between 5 and 4 is 20. So my least common denominator that I'm multiplying all 3 of my terms by is going to be 20x. Not just 20, it's got to be 20x, because the x has to be multiplied there too. That's really important. I'm going to put a little star by that. Okay, because if you don't multiply by the x, guess what? You're going to get it wrong. Okay, so we've already said that x can't equal 0, and we're going to multiply everything by 20x. Well, the x's are going to cancel in the first term, and then what's 20 times -4? Well, hopefully you're all shouting at me, it's -80, Mr. Drum. Right. Now, I have an x up here. There's no x down here to cancel it out, so I'm going to have an x, but 5 goes into 20 4 times. So I have 4 times 7, which is 28, and then I have my x. Then I have my equal sign. Now 4 goes into 25 times for my third term, so 5x times 7 is 35x. Okay. And now we have a very straightforward problem that you guys know how to do. You would subtract 28x, and you end up with -80 equals 7x. Divide by 7. And guys, go ahead and give me a mixed fraction. That's fine. 7 is going to go into -80, -11 times, so x equals -11 and 3/7. That is an actual exact answer, which is much more preferred than a decimal answer that isn't exact. This is the problem number 2. We said 5.9 was okay because that's an exact answer. 59 divided by 10 is exactly 5.9. If you do 3 divided by 7, you find that you get a repeating decimal all of a sudden, eventually. So let's try to keep it as exact as we possibly can. Okay. Now, like I said, I'm not going to go through all of these problems with you, but I am going to start off with number 5 for a minute. Okay. What is our restriction? I want you to think about that for a second. Well, I have x in the denominator, and it's by itself, so x can't equal what? Hopefully you're all saying x can't equal 0. And that's good. Okay. Now, 3 and x and 4. What's my least common denominator, guys? What does 3 and 4 and x all go into? Well, you know there's got to be an x up here. And then what's 3 and 4? Well, that's 12, right? So my LCD is 12x. So I multiply everything by 12x. What do I get when I multiply everything by 12x? Well, 3 goes into 12 4 times. 4x times 2 is 8x. X goes into 12x. That cancels out your x's, so you have 12 times 5, which is 60. And then 4 goes into 12 3 times, so that's 3x times 7, which is 21x. You may hear my dog whining in the background or barking. We love him. He's a good dog. He's old. He's 100 years old, guys, at least according to our vet. And then you can go ahead and finish this 13x divided by, or 60 divided by 13 will give you x. Clearly x is not going to equal 0 in that situation. Let's take a quick look at number 6. Okay, and then we're going to go on to our second page. Woo! I have 2x, and I have 4. Well, I'm still going to have x, right? So I have an x in the denominator. So once again, what would make this equal to 0? Well, if x equals 0. So once again, we have to say that x cannot equal 0. What is my least common denominator? Well, I've got an x down here, so I'm going to have it up here in my numerator. And my least common denominator is going to be 3. What does 3 and 2 and 4 all go into? Well, the first thing that 3 and 4 goes into is 12, but 2 also goes into that. So we're going to make that our least common denominator. So once again, even though this now says 2x, our least common denominator is 12x. Okay? So let's multiply. 3 goes into 12 4 times, so that's 8x plus, now 2x and 12x, that becomes 6. 6 times 9 is 54. 4 goes into 12x. 3x times 9 is 27x. And I'm going to leave that for you guys to finish. Okay? All right. So let's go ahead and switch over to page 2. There's some interesting things on page 2. I bet you all can't wait for this one, can you?
I can't wait.
That's my daughter, by the way. The one that has subbed for me this year.
No.
But not for you guys.
I haven't subbed for you.
Oh, never mind, she hasn't. That must have been last year. I'm getting old. All right, so let's take a look at question number 10. Okay. We have 6 plus 4 over x plus 2 equals 10. Well, what's our common denominator going to be? And do we have any limitations? Well, of course we have a limitation because we have an x in the denominator, don't we? What would make x plus 2 equal to 0? What value of x would make this equal to 0? Well, hopefully you are yelling -2, because -2 plus 2 is what? 0. So what we would have to say is x cannot equal -2. Easy enough, right? That's always your first step. Please don't forget that. Now, what's our common denominator for all of this? Well, I can't separate this because this is x plus 2. Now, this is like 6 over 1, and the last term is 10 over 1. So I have a 1, an x plus 2, and a 1. So I'm hoping you all are seeing that my common denominator is going to be x plus 2. Okay, and I'm going to take x plus 2 and multiply it by everything. What is 6 times x plus 2? Well, we have to distribute that, don't we? 6 times x is just simply 6x. 6 times 2 is 12. Okay. plus, now the x plus 2's cancel here, so I just have the 4 left over. But I do have to distribute my x plus 2 across to my 10. So I have 10 times x plus 2, that's going to be 10x plus 20. Well, it looks like a mess, but it really isn't. So I have 6x plus 16 now equals 10x plus 20. I'm going to subtract the 6x, subtract the 6x. So I now have 16 equals 4x plus 20. Subtract the 20, subtract the 20. I've got negative 4 equals 4x. And then I'm going to divide by 4, divide by 4. Let's see, negative 4 divided by positive 4, that's negative 1. And that equals x. So all that turned out to be negative 1. Now remember, our restriction was that x can't equal negative 2. Are we okay? Yeah, we're fine, because x can't equal negative 2. X can be negative 1. Exactly, Hershey. Exactly. I agree. So we're going to go through 2 more problems. There's a reason that this one has like 5 stars next to it, because it's a really cool problem. So we're going to do number 12, and we're going to do number 13 together, and then that'll be the end of the video. Okay? So that'll be the end of the notes. You guys are going to work on some things together, okay? Now, we have an x minus 2 and an x plus 2. And then we have x plus 2 and x minus 2 here. What's our first thing we've got to do? We have to limit our denominator because we have restrictions, don't we? 2 minus 2 equals 0, so x cannot equal 2. And the other thing is x cannot equal what? That's right, negative 2. I hear you all saying it. Not really, but you know. All right, so what is our least common denominator? Well, I already have an x minus 2 here, and I have an x plus 2 here, and I have both of them here. So my least common denominator is going to be both of them together. So I have to multiply everything by x plus 2 and x minus 2.
What's the matter?
It seems like a pain, but it's really easy. What happens to the x minus 2's? They're going to cancel, so I have x plus 2 times 1. Well, what's x plus 2 times 1, guys?
I don't have anything.
X plus 2. Got an equal sign here. The x plus 2's cancel out, so I have 3 times x minus 2. So 3x minus 6 minus, now what happens with all this fun stuff? The x plus 2 and the x minus 2, that all cancels out and it just becomes 6x. So what looked really complicated all of a sudden is not that bad. Let's combine everything. We got x plus 2 equals, what is 3x minus 6x? Well, that's negative 3x minus 6. So we're going to add 3x, because you know I like things to be positive. At least my wife finds me funny. Minus 2 minus 2.
Man.
4x equals negative 6 minus 2. Don't say it's negative 4. You all know better. It's negative 8. We're going to divide by 4. We're going to divide by 4. And we get x equals negative 2. Great, we're done. But what? I hope all of you realize, oh, wait a minute. Mr. Drum, you said that x can't equal negative 2, didn't you? I did say that. We have x equals negative 2. What does that mean? This is an extraneous solution. X can't equal negative 2. So, what does that mean? If this is the only solution we have, and since that's the only solution we have and it can't be a solution, what does that mean? No solution. I love my family. All right, so that's so all that work that you just did, you just found out that you can't solve that. Oh well, life goes on. It's math. You all know what math is like. All right, so let's do number 13, and then I'll stop the video, and after I tell you what you guys need to do from here on. Okay. So for number 13. We have x minus 2, and we have x plus 3, and we have x squared plus x minus 6. Ugh. That looks like us a whole bunch of different things, doesn't it? Well, it looks that way, but I know that you guys have great factoring skills. Okay? Whenever you see something that looks like it can be factored, go ahead and factor it. So we're going to go ahead and factor this. This is a simple one, right? I've got x and x. What times what gives me 6? Well, that's 3 and 2. And I want a positive 3 and a negative 2. And look, this all of a sudden turned into x plus 3 times x minus 2. This is x minus 2 and this is x plus 3. What does that mean? That means that this is my least common denominator. Great. Now, we still need to go through and say, what are my limitations? So, I'm going to write down what the limitations are. I'm hoping that you all are saying out loud to yourself that x can't equal 2 and that x cannot equal negative 3. Okay? Hopefully that makes sense, because if I plug 2 in here, 2 minus 2 is 0. If I plug in negative 3 plus 3 is 0. And believe it or not, if I plug in 2 here, I get 0. If I plug in negative 3 here, I get 0. All right, so my least common denominator we've already determined is going to be this x plus 3 times x minus 2. So everything gets multiplied by that. Okay, so we cross through our x, well, our x minus 2's are going to cancel, so I have x plus 3 times 1. That's not too hard, I hope. That's x plus 3. Then I have my x plus 3, they cancel each other out, so I have 3 times x minus 2. So that remember, we distribute, so it's 3x minus 6, okay? And what's going to happen over here? Well, this whole denominator and numerator cancel each other out, so I just have what? 4. Please don't forget to write down the 4. It's important. It'll feel lonely if you do forget. So I got 4x minus 3, combining my like terms, equals 4. I'm going to add 3 to both sides, and I'm going to have 4x equals 7, and I'm going to divide by 4. And I get x equals 7/4, or x equals 1 3/4. Is this answer okay? Well, yeah, because x can't equal 2 and x can't equal negative 3. Those are the only two things x can't equal. Okay? And guys, that's it for our lesson for today. I'm going to try to keep this short, no more than 20 minutes. If I go over by a minute or two, I'm sorry. What I need from you guys, okay, what I'm expecting you to do, I would like you to do the other problems on this worksheet first, okay? When you finish those and you feel pretty confident, you can look online. There will be available some things worked out for you. And then there's also an assignment that is already available to you. That's going to be your graded assignment. It's 5 problems. It's actually 5 problems out of the book that I have put into Schoology. I want you to solve them. A couple things you need to know is that you can, there's like a little notepad and things like that. So play around with it, okay? If you're having difficulty with it, I have office hours tomorrow, not tomorrow, yeah, tomorrow. Today's Monday. I have office hours tomorrow for your class from 9:30 to 10:30, okay? I will be online and just being able to answer any questions that you have. So feel free to send me a message on Schoology that you're having some problems. I will answer your messages for sure, but I will be available. I can't do face-to-face, unfortunately, but I will be available that we can actually do a more immediate chat during those that 9:30 to 10:30 time. Okay, so guys, I really hope you all are doing well. You know, I miss you all. I look forward to maybe getting a chance to see you all again. Maybe not. Who knows what's going to happen with all this. But at least I can talk to you through the magic of the internet. I was just thinking this morning, what happened like 25 years ago if this had happened? What would have happened with school and all that fun stuff? Interesting things to think about, huh? Anyway, good luck. Have fun. And guys, there'll be another video for you for our next section on Wednesday. Bye.